Well, thanks a lot for having me, guys, and thanks again for this amazing event that you have put together. It's of course a pleasure to be here with you. I I am happy to present some of the work that we have been developing last year within the IA context. My presentation is called Speckle'n Space, and it's an off-world case study of moon colonization through collaboration. And the topic might seem a little bit, perhaps it seems a little bit weird to you, but I think, I mean, don't take it too literally. It's mainly just an excuse. It was just an excuse for us to explore some of the advanced tools that we have nowadays in AEC, and that's why I thought it might be fitting for us to present our work in this context, especially given that Speckle was part of our collaboration during this mission that we had last year, and not only Speckle but Alan was also part of our team. Having said that, I would like to perhaps start by giving you a little bit of a context of what the presentation is encapsulating and where the actual investigation takes place. This is going to be maybe a little bit of don't consider it shameless promotion, but more or less just to paint a broader picture of where the investigation took place. So as Alan said, I am head of computational design in IAAC, but I also direct the Master in Advanced Computation for Architecture and Design Masters in IAAC, which is no more than 1 year old. We set out last year as an accredited online master program that really aims to train a new generation of designers and architects in the skills that we think are highly required nowadays in the AEC industry. Just a tiny bit about me. I am an architect with a focus in research and development of computational tools. I am currently, as I said, the head of computational design in IAAC. I direct the masters in advanced computation for design in IAAC as well. I'm a senior faculty in the Digital Matter Studio and a guest teacher in the MPDA UPC masters. I worked previously providing development support and training at McNeil Europe. And that I was a research assistant in CETA in Denmark. I did my studies in the University in Stuttgart, and I started all this kind of career here in Barcelona. This is where it all started, and I'm happy to be located back here in Barcelona. And even though this master is run online, I live here close to IAAC, where all of the action is taking place. So let me tell you just a little bit about MACAD and where does this specific investigation takes place. MACAD is yearly long masters, which is divided into 3 modules and a thesis program in the end. So there's the first module that's we have a first module that talks about advanced computation for environmental and structural design. We have another module that talks about building information modeling and smart constructions, which is the one that we will be developing the talk today. And we have also another module about artificial intelligence in architecture. So this is the topics that we considered were worth exploring and that deserved a lot of attention in terms of teaching the most advanced tools that AEC demands nowadays, especially with my previous experience being in contact with the industry and software development. We feel that we've developed a very bespoke curriculum for what's actually needed nowadays. The program also runs into formats. So we have a synchronous format, which is for the students that manage to join in the morning of Barcelona, and we have an asynchronous format for those in different time zones who can join in the afternoon of Barcelona time. And this is going to be important later in the presentation when we start to talk about the collaboration that took place in the studio. So as said, the first module is on advanced computation and environmental and structural design. We have the second module in building information modeling and smart construction. And we have the third module in artificial intelligence in architecture. And these are all modular, which means you can take them separately as a postgraduate, or you can take the whole thing as a master program and have an accreditation in the end after going through your thesis. So I'm going to place the context of this conversation in this particular module that we developed. That's the building information modeling and smart construction, and mainly focusing on the work that we developed in the studio of this module. For each of these modules, we have one theory course, one studio, and basically three seminars that teach the tools themselves, like the technical knowledge. And what takes place in these seminars is basically that they complement the studio into developing a larger scope project. So for this particular module, we focus on basically digital tools for integrated modeling, which means mainly interoperability, basically using Rhino Insight and Revit. Digital tools for collaborative workflow, which is where we use the Speckle and where more of this talk is going to be developing in the next minutes. And then digital tools for cloud-based data management, which is basically managing data in order to design interfaces to the web, mainly using Rhino Compute. So my talk is included within the BIM and Smart Construction Studio, which is the studio that I taught in this particular module. I myself, along with Anna Taut as faculty assistant, which is also the coordinator of the program, and our computational experts, we basically headed the team of the studio. But we were also very happy to be supported with other faculties from the other seminars, as I spoke before, which among a larger amazing group of faculties that we have putting together, thanks of course to the benefit of reaching out, being able to reach out abroad. We have the support of this brilliant group of people, and in particular those that I've selected here are those who have participated in the BIM and Smart Construction module. I guess you can see a familiar face there already. Our eloquent moderator was also part of the team and very much included in the work that I'm presenting today, of course. But I mean, further than that, and even more importantly, we had an amazing group of students that joined the first edition of the program, 34 at the moment that the studio took place, coming amazing, brilliant professionals and people from many different backgrounds, all tied together around this topic of developing tools for AEC. And we're very proud of course, of the high diversity that we can manage. So, of course, given the fact that this program is online, and we can reach out to teach these tools without borders, without limits. So, in the first glance, you would probably wonder why the studio, or why the module itself is called BIM and Smart Construction. And I borrowed this graph that I saw from the Genie Belt at some point in a website to actually explain that we would focus not in the let's say canonical BIM or the more hardcore BIM practices that happen nowadays, but we would aim to focus more on other interesting topics that we think represent current challenges in BIM nowadays that are not so platform specific, and also are topics that are part of a larger interesting conversation, such as integrated modeling, basically documenting plans, creating schedules, budgets, and doing so in a manner that it's common, basically that in a common platform. As I said, cloud-based data management, which is basically bringing these interfaces to the web. Collaborative workflows, which means basically establishing workflows to share and work together in a common project in between different rates, different time zones, different time schedules, different programming languages, of course. And that also falls within interoperability, which is the current challenge to be able to transfer data from one software to the other. And all of this, of course, I think you start to see where this talk starts to fall into the scope of the specific event. So we of course tried to address certain questions or certain challenges that we thought were interesting to tackle without having to, as I said, develop a BIM course on Revit or another platform to just document the project. And that was mainly to pose questions such as how to design projects so that they are able to adapt to the various changes of the design development processes. And here, very well explained by the famous McLeamy curve, where you can actually acknowledge that an architectural project becomes more difficult to change the more developed it becomes. So this has to do a lot with the tools that we developed throughout the masters, and also has to do a lot with parameterizing these projects, with the complexity of these projects and the many dimensions that these projects achieve, and how to actually anticipate some of the problems that you might face later in the later stages of the construction process. Also, how to collaborate robustly and freely and in real time with different agents of the design process. Another challenge that we identify and we really working to address in the studio. And finally, how to transfer architecture information along the many software design softwares that are out there. Of course, most of our program is based in Rhino, and we feel that Rhino it's an amazing academic tool to start on computational design, but also it has now the flexibility to talk to other programs, to other software, and to enable this intercollaboration that we speak about. So a little bit about the studio, basically the studio timeline, what we thought would happen throughout the whole studio, which was actually only 10 weeks long. Keep in mind that these are separate modules, so each module is no longer than 3 months. So we had only 10 weeks to develop this project. And we thought we started with basically the site placement, which would be the strategies to place many different projects in the context that I'm later going to be speaking about, which is going to be the moon. And then the project documentation, which would be to actually document the projects properly and bring them to a level which is actually beyond the Rhino interface and more into already BIM standards. And then even web interfaces, so actually pushing our projects beyond the software into the browser and allowing for parameterization there. And this changed, of course, during the duration of the studio, because we actually we realized that the site placement side or the collaborative side was not as easy as we thought. So it didn't only took the first part of the studio, but it actually took a larger chunk in the end. And that's where basically Speckle also has a big role in the process. So I also want to I'll tell you a little bit about the site that we chose. So basically, we chose the moon as a kind of a rather nuanced, fun, context to develop our projects. But not only for the fun side of it, but also because we thought it would force the students to create bespoke components within their projects for non-standard projects, meaning escaping, the canonical shapes that we commonly use to construct, and also provide a unique opportunity for storytelling. Where this would also provide, more freedom of design and program within specific constraints, and allow the students to exercise their abilities and creativity to challenge problems. And we were also very keen on developing a unique aesthetic quality to the project, which is something that at the end we're very happy that it happened. And then why not? We thought this was actually a very trendy line of research and design now. So it's a very plausible challenge for the near future, and more, of course, more. That's on top of it being just plainly fun to develop projects from the moon. So we actually took up, we started by giving the students a site, which we thought was an appropriate site, with not so much thought. Of course, we weren't counting on the importance of the site so much, because this would only be an excuse for the students to develop their projects further. But actually, our students took this super seriously, and the minute that the studies started, they started to do research about the site super passionately. They were looking into many different sources. It was amazing to see our Slack channel, which is actually the soul of the mastery program. It was flooded with people throwing in information about which would be the best possible site to develop the project on, and so on and so forth. So even though this wasn't actually the focus of the project, it was amazing to see that the students took it. We're so passionate about finding actually the best site for settling the colony of projects in the moon. And they found a new suggested site, but not only that, they built up a whole presentation about why would this site be much more feasible and more possible, a realistic landing scenario for actually developing a colony in the moon. There was, as I said, tons of research. These are just images that I gathered from our Slack channel now and then, and they even came up. They even found the 3D model upon which they would work upon. So this is actually the site where we would place the project of the studio. They actually pinpointed a smaller chunk, because the crater, of course, is huge, it's kilometers long. So they actually selected a smaller chunk of the site, considering, of course, orientation and slopes, and of course solar radiation and all of these kinds of stuff that are very intricate to off-world design in a way. And as said, we were quite impressed with the fact that even though this wasn't the main goal in the beginning, this happened in no time, and these guys were really excited about doing things right and setting a proper site for their project. So the new site was established. We gave it a go, and we actually decided on the Shackleton crater as a site for our projects. And then at the same time, we actually also gave the students a program for them to develop the project, so that this would be the way that they were actually distribute the projects among themselves. So they gathered in groups of 3. And I think we even had a couple of groups of 2, one group of 4, and both for the guys in the sync format, which attends the courses in one specific time zone. For the async format, we actually gave them a couple of suggestions for certain programs to develop their projects, but they actually it was nice to see that they also research upon what would be either suitable or in a way fun for them to develop. So we had really cool programs like a meditation temple. We had a couple of moon residencies. We have garden and wildlife reserve. We have a space factory, and we have an entertainment center. I mean, in the bottom, this was in the very beginning of the studio, and more or less included in the brief. But at this point, it was amazing to see the huge engagement that we could get from the students. So the mission was actually to build a permanent colony on the moon that could sustain for 100 settlers. And then there was here comes the challenge, and here comes where the advanced tools are needed for intercollaboration. So posing the problem of revisiting the problem of how to collaborate robustly and freely in real time with the many different agents of the design processes. We actually gave them, instead of it gave them in specific site locations, the goal was to create a challenge for the students. So we actually came up with certain rules of settlement, where they would actually have to respect in order to form the colony altogether. And for instance, one was to define a maximum project radius, which they would have to specify for the projects according to their programs. They would need to come up with at least 2 minimum connections in between the projects. And these connections would eventually signify the transportation network in between the colonies so that the projects are tied up together. So there was actually, they would establish this minimum of 2 connections to other projects in the site, and also a maximum distance in between the projects, so that the connections couldn't be further apart than a specific distance. But more importantly, the mandate of the settlement rules was not to allow for any centralization. So that means that no one would take the role of the urban planner. That means that no one would, because these guys were also working, each of them in every other countries, there wasn't the chance for them to sit on the table and actually discuss and develop a urban planning for the site. So that's where the challenge actually started. And there's where the collaborative workflows, both as a topic and as a seminar, was introduced. So it was quite an experiment, because we instead of giving them a prescriptive solution for how to do this, we told them everything else to begin with, right? So at the beginning, they started with what they knew, with a lot of parameterizations attempts of each of the projects, and building connections, parametrical connections in between each of the groups. But of course, just to realize that every time that this was had to be somehow managed by one agent, and in the end, that the minute that something changed in one of the projects, that all of the other projects would have to adapt. So this was no good in the end. Later along the day, they actually also explore more dynamic solutions, such as the spring-based designs, where you would actually try to input the rules, and then all of the projects would move along. But in the end, no one in the end was happy with the situations that they would get, and they also had certain demands for their projects specific to their programs. For example, they wanted the temple to be in a central place, and that the solar plant would be kind of far away from the colony, and so forth. So this was also another more or less like centralized approach, where they would quickly realize that there wasn't much collaboration in between the projects happening. Next, hold on, there we go. Next, they also tried to bring this into a common platform by trying to specify certain parameters that they would declare from the projects that needed to be respected, and they developed basically these many dimensionalities of their own projects into a Google Sheet spreadsheet, and they had a reader that would actually read and push the information of that they would actually be managing on their own, of their projects, into the spreadsheet, and then read upon that. But that was actually not interactive enough, because I mean, the decision that one guy made, that the neighbors made, wouldn't actually be affecting you directly, and unless you actually would update the project, and you wouldn't know necessarily at which point of the workflow you're situated in. So in a way, they also came up with, they realized that they had to structure their desires to settle in a bit more of a diagrammatic way. So they actually met together. They were making efforts to meet together. The sync group in the mornings with the async groups in the afternoons, in spite of all of the time zones difference, in spite of all of the challenges that this implies in terms of organization. But it was amazing to see that how resourceful these guys were in terms of trying to come up with a solution. But it also became quite evident that the simple problem of self-organization, it's not an easy one, right? Because the minute that you move a piece, and the whole board changes in a way. So, and you can imagine all of these projects in the same board, moving together all at the same time, because they were actually the development of the project would force them to change their areas and their connections in between them. So it was actually quite hard to achieve. So finally, here comes Speckle to the rescue. And the guys also started a little bit later in the module. They started the Speckle course, which was led by Alan as a faculty, and he immediately directed them, actually introduced them to this world where you could actually collaborate in real time and sending and pushing and reading streams, while actually actually visualizing what all of the other guys are doing sort of in real time. So they came up with a spreadsheet where they would actually organize themselves in terms of program, what neighbors that they would place themselves into next to each other, and more important than that, they shared each of their streams, the project streams, to each other, so that they could actually then read them all together in their file. So this is what was there in a way in the beginning, like the very simple abstraction of their projects by areas situated in the field, and a bunch of streams, one stream for each of the groups, so that you can actually visualize these projects located in the site and how much of an area would they actually occupy, right? So this was basically the ending configuration, and then the idea was that this would start to develop kind of this transportation network, with the connections that they have actually built among the projects, and the final picture of the projects that look like something like this. The projects with their actual shape, located in the site, and connected to each other by this network, which was something that they have actually anticipated to incorporate into the projects as the infrastructure. Right, so that's basically the main idea. And even though the infrastructure was never quite developed, it didn't really matter, because the idea behind this exercise was more or less to, on the one hand, acknowledge the difficulties of trying to collaborate in real time, and the different the tools that are exploring the different tools that are out there, in order to actually achieve a balanced state, in which all of the conditions, the specific conditions of the project, but also the global rules that we have decided for, would fulfill. It was in parallel during the seminar that Alan taught. While the studio was happening, they also had seminar classes. They would actually be forced or asked to develop diagrammatically their desires, or their workflows, not only the ones in between the projects, but actually the workflows among their own groups. And because the idea was that this was an exercise of collaboration, that each of the integrants of the group will also be able to modulate the different aspects that they would actually be working on in the project themselves, and this would eventually merge into one whole project. So the intercollaboration was not only taking place in between the groups, but also in between the integrants of the groups to develop the project itself, right? So it was nice to see how were the tasks actually divided in between the groups, and you can see the different kind of an agreement of the different types of aspects of the different projects. And this is only one of them, where you would see different workflows and different streams, and how would, for example, in this case, Sergey, Natalie, and Joao would share the parts that they were working on in between the group, without actually, in a way, flooding the project, but sharing just what's necessary. This is basically another example of the same, another group that developed, came up with a very broad workflow for their project, in which there was many different sides to it, represented also by the different stakeholders of the project. So they would actually empower the client to take certain decisions, then Then the designer would be responsible for certain parts of the project, like the design of the units. An engineer would be in charge of the structural and environmental side, and then the client could actually review at the same time. And at the end, there was another stake for the digital fabricator. So during the course that the collaborative workflows course, they were asked to develop these entity diagrams, which would conceptualize the correlation in between the different stakeholders, but also the flow of the different data streams that they would have to produce in order to make this project happen, right? So you can see that the client has one branch, the designer has 7 branches, the engineer would have another branch, and so on and so forth. And then there would be one stream holding up the whole geometry of the project, which would be the one that they would push to the colony. So here's what that looked like for this particular project. You would see that, for example, there was a human UI configurator for each of the stakeholders, and each of them was kind of in charge. They had their workflow separate, so that the client could actually determine the best configuration in a different scenario. The architect would have, for example, would run into many iterations of the project and actually choose which would be the one that's more feasible. The engineer would make then actually a structural verification of that project, and then at the end, all of these through Speckle would also be pushed to Revit for documentation. So here you would actually see the entity diagrams that they built, conceptualizing each of these workflows, which was actually paramount for them to understand what was the required, what was the required steps and the required responsibilities of each of the stakeholders in the design process. So I think it was a nice exercise where at the scale or the scope of the studio project, they actually managed to tackle some of the challenges that AEC faces today. And finally, with maybe to leave a couple of minutes left, I want to show you the outcome of the project itself, not only the collaborative side, but I'm just going to quickly browse through one of our projects, actually the one that I showed you right before, which is the lunar residency. This lunar residence was developed by Marisa Hesham and Herman. This was they always had a calendar from the beginning of the studio where they would actually try to calibrate the phases in which to develop their project, and they would have actually an initial research stage, and then they would have more like a development stage. And at the end, everything came together, merging the three, actually the knowledge that they gathered from the 3 other seminars into one project that contained everything. Right. So this is the guys all ready to go to the moon. Basically, this is the aspects that they developed, and I'm going to browse this quite quickly. So they actually aim to develop a safe, self-sustainable community in the moon that's not only that not only basically solves the technical challenge that is research, but that becomes self-sustainable and thrive on the moon. So for that, they included specific design drivers on the project, like modularity, adaptability, self-assembly, individuality, the opportunities of that lunar gravity provides. And the question was whether they would be able to design a holistic system that can react to the multiple challenges of inhabiting the moon. So there was a very nice initial research on project references that they thought were relevant, even the most conceptual ones, but actually more into actually the more realistic ones, such as many of these projects, which are in a range from conceptual to pragmatic. They all contribute to somehow the development of this project itself. And also there was a very nice background, also supported by the huge engagement that these guys had into investigating for the most suitable materials and fabrication techniques that would be possible in the moon. So they were looking for moon-based materials like regolith. They were actually using ice as part of the project. But further than that, they actually dealt with their project in a very nice manner. So they would actually they would divide their project into private and public, and this is because you will see later that the project was actually quite very well structured in different scales. And this is here, it's represented right here, where you would have in one hand of the scale the broader community or the huge aggregation of the components, and that kind of is dissected all the way to the components, to the main components that actually compose the building units. So all through this process, there was zooming in and zooming out of the levels of detail that they would have to look into the project, making sure that there's a coherence in between across all of them. This is some of the tests that the guys made for their modules, and you'll see that they made actually a huge effort on making the pieces fit, and so that they also become recyclable. So once and expandable. So once that you actually need to expand, you can add more pieces, or if a module ceases to exist, then you can put it somewhere else. And there was huge studies on the circulation and the self-sustainability of the project, and even the diving into the manufacturing of the pieces based on of course, new paradigms of robotics, but also new materials that would be available on site. Right, so they were using simple materials, and they had these really nice diagrams about, of course, always speculative, but very trying to be as realistic as possible of how to put this project together in the end. And then this would actually operate in the various different scales. So then one of the most important aspects of this project was aggregation tools. So through WASP and other optimization platforms, they actually explored many different options, and it was quite important for them to think about the whole fabrication process, and where, like from the start of the colony to the whole life cycle of the community. In terms of the documentation, they actually intended to export all of this through BIM to BIM documentation. And this is what they did. So they used the different sides of the same definition and divided it into different aspects. In the end, exporting it to Rhino or interoperating with Rhino for Revit for the BIM export, and eventually also to the web stream. This is mainly the app that they generated. They generated an app which they could actually, or you could actually parameterize this on the web. I'm going to, I could share this video with you, but you could actually, there's a site where you can actually tap into this interface and create your own linear modules, because this has also been pushed to the web to Rhino Compute. And further than that, they generated this amazing planning documentation in Revit, where you can see that not only that the static quality of the project is very valuable, but also you can see the meta, the extra information, the extra dimensions that are required to do the project, such as materials, material quantities, schedules, and so on and so forth. So here's the project located on the site. Here's one instance of the project, and the plans in Revit that came out from Revit. Here's some more images of the project. These are just kind of very nice axonometric views that they produced. I'm going to correct. I'm going to stop probably right here, showing some of the nice images that they developed. And this is, of course, just one of the projects that got developed in the program out of many other amazing projects that we had the chance to conceive. So that's it. Thanks a lot for hearing me out. You can always reach me through my email if you have any questions, or if you're interested in joining the program. Of course, you're always welcome.
Awesome. Thank you very much, David. Let's leave a minute or two so the viewers, if they have any questions, have time to dump them in the chat or in the Q&A section. And if not, it's been great having you. It's always a pleasure to revisit the students' work. I hope everyone enjoyed it, and hopefully they have some ideas after seeing how to collaborate with Speckle in a complex scenario.
For sure. Thanks a lot to you for inviting me to the talk, but also for contributing with such passion to the masters and to the projects.
Yeah, you're welcome for inviting me. It was a pleasure. It's a stressful pleasure, but a pleasure nonetheless.
If there's any questions, I'd be happy to take them. Let me just...
I think we have some shy viewers today.
No worries. We can give them some time if you want.
Yeah, we can give them.
Otherwise, maybe I have a question for you.
Yeah,
so
shoot.
Maybe you want to also share a little bit of your experience in this process, because it's a unique opportunity to have you as a moderator and also as a faculty. And maybe,
Yes.
maybe it would be not to put you on the spot or anything, but
I think it was interesting. It was also a time when the Speckle as a product wasn't as developed, so we were kind of like going on the fly, figuring out the limits of the platform and the bugs that we had introduced. So there was like a complicated part on our side, but it was very interesting to see how the students very quickly got the hang of the streams and the branches and the way we organize data in Speckle, and started using it to their advantage, like within days of actually telling them what everything means and how everything works. They had already set up super complex workflows with multi-step implementations, like figuring out how to get the updates from the other teams, the updates from their own team. So it was interesting. Everyone understood different layers of collaboration because they do change project to project. So we had like a big project that had many different small projects inside, and each team had their own way of organizing their own internal design workflow, and the entirety of the project had a kind of like common agreed upon way to share the information, and they didn't have to match exactly. That you just needed to adapt to where you were sending and how, like what phase of your project you were at. No, so it was super interesting to see how they managed to kind of like update their own projects without bumping into everybody else's in the way, which is a problem in our industry for sure.
Yeah, for sure. It was nice that even though, I mean, it wasn't entirely, it was quite explorative. I think that in the end, they themselves figured out the Speckle was the right tool. So even before the seminar started, they started to develop the first version of a Speckle, the old version of a Speckle. And we really got lucky that the guys got to learn the new the 2.0 version, because I think it got released just on time for the seminar. You know? So they probably were one of the newest beta testers for the second version, and I hope they got to break something. And
they did break stuff along the way in the connectors, in the server. It was fun to watch, you know, once you have something live and people are actually using it, how they can manage to break it. So it was a very, very didactic experience also for us and at Speckle. And we got a lot out of it too, in the terms of how people want to use the platform, how they're using it. So it was, at least on my behalf, it was super nice. I hope the students ended up with a good concept of how to work together, even though they may not use Speckle in the future, may use our Ultra Enemy BIM 360. But again, the workflows and strategies are still valid. No, you just need to extrapolate them to different services that you end up using in whatever practice you end up working at. I think we have a couple of questions in the Q&A. Andrea Almeida is asking, did that interface with sliders was inside Rhino? I think he's referring to the website one.
Right, let me get that one first. So no, basically the interface that you saw with the project was on the web. So they had first developed the project in Rhino, through human UI, but later on they pushed it to the web with Rhino Insight, which was actually with Rhino Compute, which was actually the doing of Luis Fraguada and Will Pearson on the other seminar that they had, which was the cloud-based data management, where they learned to upload their Grasshopper definitions into the cloud and actually had the project running there in a website. So basically the sliders and the interface that you saw was generated for the web. And I see there's another question, I think.
Yeah.
So what was the timeline for the whole development of the project? It was 10 weeks. So that's what the module lasts, more or less. And setting aside some really nice midterm and final reviews that we had, where we had the chance to bring people from the European Space Agency and people from BIM managers from Herzog and Demuron and people from all of the kind of different aspects of the studio. Aside from that, it was basically 10 weeks of development, which is, I think, impressive in my view to develop so much stuff in such a few time.
Nice. I think we have another one. What are your plans for this year's batch?
I think that's one of our students, actually. So I won't unveil anything. But as I said, I mean, the lunar colonization turned out to be a fun experiment for everyone. But we said in the beginning that it can be the moon, it can be Mars. We could do it on the desert or in the polar caps. It's just basically an excuse to find an empty terrain which would give you challenges, right? So we might set our colony next to that one on the same moon, and build up on that one, or we might just go to another planet.
Find another solar system to land on this time.
So hey, I see Dimitri's there. Time change in Australia threw us off. So hi Dimitri. Basically talking about time changes in Australia. Just maybe a last comment. I think now that you're talking about time changes, that was basically one of the main challenges of the whole thing, right? Having people in Australia working with people in Barcelona, working with people in LA in the same group, and then all of them intercollaborating all together.
Cool. Well, if there's no more questions, we won't hold you any longer, David.
No worries. I'm eager to see the rest of the events too. So
yeah, there's some very nice chats today going on, so feel free to go watch them. Anyway, thank you very much for watching, and thanks, David, for entertaining us for an extra hour.
It's been my pleasure, guys. Thanks, Alan, Dimitri, and Mateo. See you soon.